Hey everyone, welcome to assignment 37. This is also solving day 4. Um, solving day 4, we've said everything there needs to be said, so really this is just practice. I might encourage you to open this file in Teams, solving reminders. These are all the common mistakes that people make and what you should be thinking about and why you should be thinking about it. So if you haven't taken a look at this yet, you might want to go through this. It sounds very reminiscent of the last few videos we've talked about. So a little bell work today. Yeah, how about this one? Tangent squared x minus 6 tangent x plus 5 equals 0. Shh, don't give it away. Okay, please solve that equation, and we want 0 to 2 pi. Hey, how'd it go? Did you factor that trinomial? Tangent x minus 5 minus 1 equals 0. Sure, tangent x minus 1 equals 0 when tangent equals 1. That's pi over 4 and pi over 4. And then this one, tangent x equals 5. And what did I say in that last video happens with this? That's right, most students cross that out and say tangent can't equal 5. But please remember that the graph of tangent looks like this. And so, yeah, it in fact has to cross y equals 5. And what did I say in that last video to do this one? Literally this. Graph tangent in y1, graph y equals 5 in y2, and set your viewing window. How about 0 to 2 pi? 0 to 2 pi. And, we want to see that y value of 5 show up. So I'm going to go up to 10. And we wanted tangent x. And we wanted 5. Do we see 2 points of intersection? Well, let's take a look. Yeah, got 2. Second, calculate intersect. Okay, so can't quite see my cursor. There it is. Enter, enter, enter. And I get 4.515. And then this other solution, they're pi apart from each other. So I could just do 4.515 minus pi and get 1.373 as my second solution. Or second, calculate intersect on the calculator. Okay? Okay, watch out for that. How about this one? This looks exciting or interesting. Sine 2 theta cosine 3 theta equals cosine 3 theta on 0 to 2 pi. And I kind of want to do all solutions too. But one at a time. So let's look at solving that. Okay, what'd you do? Did you divide both sides by cosine 3 pi? I'm sorry, 3 theta? Because if you did, I'm crying. Yeah, because we're throwing away solutions then. Please don't throw away solutions. Instead, I think you should do like we did in that earlier video, where we move these things onto one side. And so now we've got sine 2 theta cosine 3 theta minus cosine 3 theta equals 0. Now we've got two terms, and we can factor out a cosine 3 theta. And what are we left with? Well, if we take this out, we still have that. Sine 2 theta minus cosine 3 theta divided by cosine 3 theta is 1. Many students still putting a 0 here. Okay, and now we set each factor equal to 0. I've got cosine 3 theta equals 0, and here sine 2 theta minus 1 equals 0. And that means that sine 2 theta is going to equal 1. When does sine equal 1? Well, sine equals 1 when 2 theta is pi over 2. That's the only time on once around, but we need to go twice around. So 5 pi over 2 is the next time. And if I divide everybody by 2, I'm going to get that theta equals pi over 4 and 5 pi over 4. Okay. We didn't finish that one. Cosine 3 theta equals 0. Cosine is equal to 0 at pi over 2. 3 pi over 2, 5 pi over 2, 7 pi over 2. I got to go around 3 times. 9 pi over 2 and 11 pi over 2. And divide everywhere by 3. So I end up with theta equals pi over 6, 3 pi over 6, 5 pi over 6, 7 pi over 6, 9 pi over 6, and 11 pi over 6. 12 pi over 6 would be 2 pi, so we're inside that boundary. Don't forget these solutions over here as well. We've got pi over 4 and 5 pi over 4. These are our solutions on 0 to 2 pi. Now, what about the all solution situation? Well, everything's going to be the same up to here and to here, but once I get here, instead of going around 3 times, or instead of going around twice, I'm just going to go around once. So here, when is sine equal to 1? That happens at pi over 2. So 2 theta equals pi over 2 plus 2 pi n. And then divide everywhere by 2. So theta equals pi over 4 plus pi, because I'm doing 2 divided by 2, pi n. So I've got those solutions. Now what about over here? Well, cosine equals 0. I'm only supposed to go once around. So I got to get rid of all these other ones and say, okay, pi over 2 plus 2 pi n and 3 pi over 2 plus 2 pi n. That's what 3 theta is. Now let's divide everywhere by 3. And so our other solutions then are going to be theta equals pi over 6 plus 2 pi n over 3, and 3 pi over 6 plus 2 pi n over 3. Don't forget these from the other factor. Pi over 4 plus pi n. And there's our solutions. These would be all solutions. We did the 0 to 2 pi solutions before. Nice. Good. Good, good, good. Do you need another one of those? Sure. Why not? Sine squared 2 theta cosine theta equals cosine theta. And, 0 to 2 pi. Give it a try. Pause your video. See what you can do. All right. So move everything onto one side. Again, if you're going to divide by cosine, there's the chance, the very real chance that you're throwing solutions away. So don't. Instead, move everything onto one side, and factor. I can take a cosine out of these. Cosine theta, and we're left with sine squared 2 theta minus 1 equals 0. Remember, cosine divided by cosine is not 0. Don't put 0 there. Cosine divided by cosine is 1. All right, so we've got cosine equal to 0. We've got sine squared 2 theta minus 1 equals 0. So sine squared 2 theta equals 1. Take the square root of both sides. I get sine 2 theta equals, people are still forgetting the plus and minus. So when does sine equal positive 1? When does sine equal negative 1? Well, I know that sine equals positive 1 at pi over 2, and that sine equals negative 1 at 3 pi over 2. Since there's a 2 here, and I'm on on 0 to 2 pi solutions, I'm going to go around twice. So I'm going to get that 2 theta equals, first time around, pi over 2 and 3 pi over 2. And then the second time around, I'm adding 2 pi to each of these, 5 pi over 2 and 7 pi over 2. We still need to divide by 2 everywhere. So theta equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Nice. 2, 4 solutions. Did we go around twice? Positive 1, negative 1. Yep. This is the first set of solutions for positive and negative. This is the second set. Yep, those are my answers. Oh, but wait, when is cosine equal to 0? So that happens at pi over 2 and 3 pi over 2. Notice there was no sort of b value here. And so even though we were talking about pi over 2 for this one, as well as pi over 2 for this one became something else. And this one does not become something else. It is, in fact, pi over 2 and 3 pi over 2. These are our solutions on 0 to 2 pi. But of course, I'd like to consider this problem for all solutions. So what can we say about all solutions here? Huh? What can we say? Well, cosine theta equals 0, and we know that sine squared 2 theta equals 0. If I add 1 to both sides, I get 1 there. Okay. That's sine 2 theta equals plus and minus 1. Where do we go from here? Well, because we're doing all solutions, I'm only going to go around once. So 2 theta equals pi over 2 plus 2 pi m, and 3 pi over 2 plus 2 pi m. So theta equals pi over 4 plus pi m, and 3 pi over 4 plus pi m. Over here, cosine equal to 0. Same, isn't that? Oh no, it's that other thing. It's pi over 2 plus 2 pi m, and 3 pi over 2 plus 2 pi m. So those are our solutions. Okay. What's next? We did those. I think we just kind of did that, but maybe we should do that. I don't know. These feel a little repetitive to me at this point, but let's go with it. 2 sine squared x minus 1 equals 0. Actually, let's change that to cosine. Okay, 0 to 2 pi, and all solutions. You should be able to do both by this point. I know you're wondering why I'm paused. It's yeah, I'm answering this scrutiny question. I know, you're like, well, Koopa, pause this video and answer his question. Yeah, no, I can't pause this video. I have to make a second part. Don't worry, I think I'm almost done. Okay. So 2 cosine squared x equals 1. Cosine squared x equals 1/2. Take the square root of both sides. Cosine x on the left, that's fabulous. Now, what are the things that people are going to forget over here? Well, I agree, they're going to forget the plus or minus. And the other thing is, remember, this is square root of 1 over square root of 2. And if we rationalize that, we get root 2 over 2. So when is cosine plus or minus root 2 over 2? Well, that happens at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. These are the solutions where cosine is equal to positive root 2 over 2, and these are the solution where cosine is equal to negative root 2 over 2. Ooh, but we need all solutions as well. And so I guess many of you will still be doing this. But some of us will be saying, well, look, these are all pi over 2 apart. So I'm going to have pi over 4 plus pi over 2. That would be my answer. I certainly wouldn't mark that wrong. Okay? Cool. So how does this change if we have 2 cosine squared 2x minus 1 equals 0? Now, what stays the same there? What changes? Okay, so we're going to have cosine squared 2x equals 1/2, and we're on 0 to 2 pi, so let's think about that. We've got cosine 2x is plus or minus root 2 over 2. When does cosine equal that? That happens at pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, 9 pi over 4, 11 pi over 4, 13 pi over 4, and 15 pi over 4. So we get these 4 from the first time around, and these 4 from the second time around, but don't forget to divide everything by 2. So x will be pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8, 9 pi over 8, 11 pi over 8, 13 pi over 8, 15 pi over 8. Ta-da! Done. That's the 0 to 2 pi solution. But what about the all solutions? How do we do that? Well, we don't need to go around twice. And at this point, we could slap on plus 2 pi n everywhere. So much writing. Wouldn't you rather have the 2x equals pi over 4 plus pi over 2n, and then divide everywhere by 2? X equals pi over 8 plus pi over 4n. That would be my solution. But you guys over here are going to have x equals pi over 8 plus, don't forget to divide 2 pi n by 2, pi n, 3 pi over 8 plus pi n, 5 pi over 8 plus pi n, and 7 pi over 8 plus pi n. But there you go. Okay, don't do the dividing and then slap on the 2 pi ends. Okay, you're going to be missing solutions then. All right. We did that one. How about this one? 2 sine squared x plus 3 sine x plus 1 equals 0 on 0 to 2 pi. Give that one a go. Okay. So, yeah, I hope you factored. Don't subtract 1. Don't subtract 1. Just factor. 2 sine x equals 0. So we get sine x equals negative 1/2, and sine x equals negative 1. When does that happen? Sine is negative 1/2. That happens at 7 pi over 6 and 11 pi over 6. And when is sine equal to negative 1? That happens only at 3 pi over 2. Imagine how hard these problems would be if you hadn't memorized your unit circle. Yeah, unit circle must be memorized. Okay, and with this, since the distance between these is different, I'm not going to try and do any sort of special all solution situation. If I were asked for all solutions here, I would just write the plus 2 pi n plus 2 pi n plus 2 pi n. Okay, cool. How about this one? How about secant squared x equals secant x minus 2 on 0 to 2 pi? Okay, how'd it go? Were you successful? Did you move everything onto one side, please? I hope so. And so, does that factor? Secant x minus 2 plus 1? No. In order for this to be plus, these have to be the same sign. But that gives me plus 3, and I need minus 1. What if I make them both minuses? Minus makes plus. If that's minus 1, minus 2 is minus 3. And I don't have that. So how could I do this? Yeah, I can't seem to factor here. But, we live in the age of indoor plumbing and graphing calculators. So how about we do graphing? So I've got parentheses 1 divided by cosine x squared minus 1 divided by cosine x plus 2. So there's our secant squared. And then we have minus secant and plus 2. Okay, graph. There's our graph. Isn't that interesting that that one's a little shorter than those? I would say you should do that one for extra credit. Why is this not where these are? Write something up and give it to Mr. Paws and see if he'll get you extra credit for it. That's a good question. Okay, so now here's our question. When is this curve equal to 0? When does this curve cross the x-axis? Never. Okay. Now, what if instead I had that? Okay, that one does factor. Secant x minus 2, secant x minus 1. And so I've got secant equals 2 and secant equals 1. Some people need to say reciprocals. Cosine is 1/2. Cosine is 1. So when is cosine 1/2? Well, that's at pi over 3 and 5 pi over 3. And when is cosine equal to positive 1? That only happens at x equals 0. Okay, so isn't it interesting? Just, changing one little symbol, we can go from something that has no solution to something that has these 3 solutions. Cool. Okay. What are you going to do here? Sine x plus cosine x equals negative 1. Okay. This is the one where we said we needed to square both sides. So sine x plus cosine x times sine x plus cosine x equals 1. Okay, so I FOIL. I get sine squared x plus 2 cosine x sine x plus cosine squared x equals 1. Right? Because cosine times cosine is cosine squared. Here we have sine times cosine. Here we have sine times cosine. One of them plus one of them makes 2 of them. Okay, now what? Well, I could rewrite this as sine squared plus cosine squared plus 2 cosine sine equals 1. And what's that equal to? 1. 1 plus 2 cosine x sine x equals 1. I subtract, and I divide 0 by 2, so I've just got this. When does cosine equal 0? When does sine equal 0? All right, well, let's talk about that. Cosine equals 0 at x equals pi over 2 and 3 pi over 2. And when does sine equal 0? Sine equals 0 at 0 and pi. I'm not including 2 pi because 2 pi isn't included. Okay. So this feels pretty good. We have all these quadrant angles, right? All right, well, do me a favor. Let's go back and graph our original problem. Our original problem was sine x plus cosine x, and in y2 we have negative 1. Oops, I need my glass to go deeper. Let's change that. Okay, window y min, 3, y max, positive 3. All right, so here's sine plus cosine. And here's the line y equals negative 1. And we've only got 2 solutions, 2 points of intersection. But we came up with 4. So let's help with that. Second, calculate, intersect. Bring my cursor close to the point of intersection. Enter. So I get 3.14159. Oh, that's pi. Pi is one of the answers. And let's find that one. Second, calculate, intersect. I know you're saying 3 pi over 2, aren't you? It's not 2 pi. Or, yeah, let's, okay, what do we get? We get the second solution is 4.712389, which I believe is 3 pi over 2. So let's check that out. 3 pi divided by 2 is, yep, 3 pi over 2. Those are our only 2 solutions. So that's a solution, and that's a solution. That is not. And how come? Well, remember what our first step was? And remember, when you square both sides, you are now in a must-check situation. Hate to tell you. Must-check. Yeah, it doesn't stop being a must-check just because we've left pre-calc. Yep. All right. I think, do I have one more? I think I might have one more. Oh, yeah, this one. Why would I do that one? Oh, no, we're not doing that. No. Sorry. I have some other problems here from a time when we did more things in this chapter 5. We used to do sections 5.4 and 5.5. And when you do solving in those two sections, it's yet more complicated. That material in 5.4 and 5.5, yeah, no, it doesn't show up on any test that you're likely to take after this class. And so really, there's no point in being really old school about it. But, you might find some interesting stuff in there. Um, and you should ask Mr. Paz about going through those sections or not. But I will say, yeah, no, I'm not going to go through it myself. And I think that's it for the day. Except I'm going to say one more time. You should make sure you know all of this. Okay. Have a fabulous day, students. Take care.